Hey everybody, welcome back to Welch's math class. We are here once again doing our dance, doing math. Yes, we are. Are you excited? Aren't you excited yet? No? Oh, come on. Come on! Let's go! Get excited. Math. Algebraic equations. Special situations. That's what we're going after today. We're going to go after a couple of special situations in solving some algebraic expressions, or algebraic equations. We're going to go after a couple of special situations and show you some things that I think could really be helpful to you in solving some of these equations. The first thing that a lot of my students struggle with, they tell me they struggle with, are solving equations that have fractions in them. So for example, let's say we've got the equation y over 2 minus 4 equals y over 4 plus 2. Okay, so y over 2 minus 4 equals y over 4 plus 2. And let's say we want to solve that equation. One of the things we can do, because the fractions really bum a lot of people out right here, one of the things we can do is we can work on clearing the fractions. We can work on clearing the fractions. All right? So what I want to tell you is we can clear fractions. We can clear fractions out of an equation by multiplying. Okay, so we can clear fractions out of an equation by multiplying each term, T-E-R-M, I can spell, I promise, by multiplying each term by the least common denominator of the given fractions. Okay, let me say that again. You capture it in your notes, but let me say it again. We can clear the fractions out of this equation by multiplying each term in the equation. This term, this term, this term, and this term. We can clear the fractions out of the equation by multiplying each term in the equation by the least common denominator of the fractions that are there. Well, the fractions we have are y over 2 and y over 4. Y over 2 and y over 4. Alright? So, with those two fractions, my LCD is, what do you think the LCD is? Least common denominator for 2 and 4. Or for y over 2 and y over 4. How about 4? That's the smallest number they both go into. Or 4 over 1. 4 over 1, same number. 4 and 4 over 1, same number. And we can use it whichever way we need, but if we'll multiply each term in this equation by 4, or 4 over 1, fractions will go away. They'll just be gone. Let's take a look at that and kind of see how that works for a quick second. Let's suppose we erase this, so we'll have a little space to work with. Capture this in your notes. You'll have it up to this point. We know that the LCD is 4, or 4 over 1. And so what we're going to do is one by one, we're going to go through here and multiply through. So let's do 4 over 1 times y over 2. That's the first term, right? So what happens when we multiply fractions? Well, we can do that cross-cancel thing. Remember, we can cancel the 2 with the 4. This will become a 2. This will become a 1. And now we can multiply 2 times y is 2y. And 1 times 1 is 1. Now we get 2y over 1. But all we got to do, guys, is just simplify that straight up to 2y. 2y over 1 is 2y. And so my first term in my new equation is 2y. 2y. All right? That's my first term in my new equation. My second term in my new equation, I'm going to multiply the second term, the negative 4, even though it's not a fraction, I'm going to multiply it times 4. Okay, so negative 4 times 4. It's going to be negative 16. Okay, remember I can multiply by either 4 or 4 over 1. If it's a whole number, I'm multiplying by 4. That's a little easier. If it's a fraction, I'm multiplying by 4 over 1 so I can see my canceling that would happen. So I'm going to do that negative 4 times 4 is negative 16. So my second term is negative 16. Okay? Now I'm to my equal sign. Now my third term, or my first term on the right side of the equals, I'll multiply y over 4 times 4 over 1. Now the 4 will cancel the 4 and become 1s. We'll get y times 1 is y, 1 times 1 is 1, and y over 1, which is y. There you go. Y. Why? Why am I so... Y'all just need to watch. You'll be good. All right? That's why. So you can do this. All right, so my y over 4 times 4 over 1 equals y over 1, which equals y. So this term becomes a straight, just plain y. And now my last term, I'm doing this term by term. I'm going to simply do 2 times 4, multiplying everything by 4 or 4 over 1, so I'm down to the last term. That's going to equal 8, so that's a plus 8. Plus 8. So guys, when I multiplied everything in the equation, this, and this, each of the 4 terms, by 4 or 4 over 1, the fractions, you notice now, are all gone. So what I end up with, give myself a little space here, what I end up with is 2y minus 16 equals y plus 8. Now that the fractions are gone, I'm just going to handle this like a regular equation. And so I'm going to see if I can simplify on both sides or either side, and I can't. No like terms here, no like terms here. The second thing I'm going to do is I'm going to go ahead and say, okay, well, let me transpose. So I'll transpose to get my y's together. I'm going to leave my y's on the left, so I'll have a 2y over there on the left. This is a positive y. When it jumps across, it becomes a negative y. If I'm going to put my y's over here on the left, then I want my numbers that aren't y's over here on the right. And so this negative 16 comes across, becomes a positive 16 plus 8. Okay? So there's my transposing. Let's simplify that. Now 2y minus y equals y. Don't worry, I'm not going to go y again. I just did though, didn't I? Sorry. 2y minus y is y, and 16 plus 8 is 24. And now we have our solution to this equation is 24. Good deal. So there's a situation, special situation, where we're able to clear the fraction out by multiplying each term in the equation by the least common denominator. Let's take a quick look at another special situation. Let's take a look at a pretty simple equation. 3 times 2x minus 4. Okay, there's the expression on the left side. Now on the right side of the equal, let's put 6 times x minus 2. There's the expression on the right side of the equals. All right, so let's just begin to work through this. Remember, our first step is to simplify on both sides. Simplify on both sides. All right, so 3 times 2x, 6x. 3 times negative 4 is negative 12. Good. Simplify over here on the right side. 6 times x is 6x. And 6 times negative 2 is again negative 12. Wow. What we have on the left side, we should notice right now, is exactly the same thing as we have on the right side. So they're exactly the same. 6x minus 12 equals 6x minus 12. Well, what that tells me is any number I put in for x is going to match what I put in over here. I could put any number in right here, and I put the same number in over here, and it's going to work. So essentially, any number will work as a solution for this equation. Let's carry it on out and kind of see what it looks like if we carried it through to the end. Now, to do that, let's go to step 2 of transposing. All right? If we transpose, we're going to get our x's together. The x's over here on the left. There's a 6x already there. Positive 6x comes across, becomes a negative 6x. Let's get our numbers that don't have x's over on the right. So the negative 12 comes across, becomes a positive 12. It's over here with the other negative 12 that's already there. Now guys, notice 6x minus 6x, no x's left, that's just 0. 12 minus 12, of course that's 0. Anytime we end up, if we don't recognize it up in here, all right, that these two are exactly the same, anytime we end up with 0 equals 0, then the solution is all real numbers. All real numbers. Okay? Any number is going to work there. All right. Got one more special situation that I want you to take a quick look at with me. Capture that one so you'll see that. This last one, let's see. Let's just see what it looks like when we put it up here. It starts out as a 10x minus a 2 times an x minus 3 equals an 8x plus 2. Looks like a very typical equation of all the things that we've worked on so far. Let's just use our 3 steps to see what happens when we begin to solve it. Remember, first, we're going to simplify on each side of the equal. Second, we're going to transpose. And finally, we'll use the multiplication principle to get the variable isolated. So let's take a look. Let's simplify over here on the left side. We'll distribute the negative 2 through the parenthesis here. So we'll end up with 10, and then that's a negative 2x, and then the negative 2 times the negative 3 is a plus 6. So a 10 minus 2x plus 6. Over here on the right, there's no simplifying to do. That's just 8x plus 2. Now, I can do some more simplifying on the left. Notice I can do the 10 with the positive 6. So that's a, what is that, a 16? You got it, baby. That's right. Negative 2x plus 16 equals 8x. Ooh. Oh, gosh, y'all. Made a little mistake. But that's okay. We can fix that. Here's what I want to show you. Here's what I want you to do. Very simple little thing here. Put an X right here for me. It's not going to change much at all. Put an X right here. Okay, that's where I want your X's. And now that's going to change this piece right here for me. All right, so put an X behind the 10 there, and X behind the 10 there. All right? All right, this is still the same. Negative 2 times X, negative 2X, negative 2 times negative 3, positive 6. Now, what's 10X minus 2X? You got it. 8X. 8X. So we have 8X plus 16 on the left side. On the right side, we still have 8X plus 2. 8X plus 2. All right? Let's keep working and kind of see what happens here. So my next step after we've simplified is going to be to transpose. So let's transpose this 8x over here with this 8x. And so we'll have 8x and minus 8x. When we take this one over, it turns from a positive over there to a negative. Let's take the 16 over here. It'll be a negative 16 plus 2. Now, what is 8x minus 8x? Of course, it's 0. All right? 8x's minus 8x's, you got no x's. So it's 0. 0 equals, and over here, we get negative 14. Now, what I want to ask you at this point, guys, is does 0 actually equal negative 14? Of course not. No, 0 is not negative 14. 0 is 0. This is just not true. And so what we have whenever we end up with an equation that 0 equals something besides 0, what we have is no real solutions. Or no solutions. There are no solutions. There's nothing. There is not a solution to that equation that'll make it work. And so that's another special situation. All right, so 3 special situations we looked at very quickly. We looked at how to clear fractions by multiplying everything in the equation by the least common denominator of the fractions that were there. We looked at when we end up with 0 equals 0, work our equation down, 0 equals 0. Oh, all real numbers are solutions. And then we ended up in this last one where we worked our equation down when it was 0 equals something besides 0, which is not true. So there's no solutions to the equation. All right. I hope that helps you. You'll have some of those that will pop up in your homework in 9-7, so hopefully it'll help you. Work hard in 9-7 there. Work through those equations. That's the basis of what you'll be doing in Math 101 and your algebra courses going forward. And the stronger you are at solving these equations, the better off you'll be in the long run. All right? Next time we're going to get together with 9.8, and we're going to do a little bit of applications, word problems. Ooh, you're excited, I can tell. You probably love word problems just about as much as you love fractions. I bet you do. So this will be a good time. I'll see you then, and we'll talk about some word problems.